Sounds good.
All right, welcome to the Global Math Department. My name is Jill Bemis and I'll be your host tonight. Tonight we are going to hear from Leigh Nataro about instructional strategies to promote reasoning and communication in statistics. Would everyone please introduce themselves in the chat window, telling us what you teach, where you teach, and what your Twitter handle is if you have one. We'll let everybody...
A lot of people have already started to introduce themselves in the chat.
I love it.
Yeah.
Indonesia, North Carolina.
Yeah, we got Taiwan.
Thailand. Oh, wow. UK.
Oh, and we got a college student too. So welcome to college student from Huntsville.
Yay.
Glad to see so many familiar. I see a few familiar names here with us tonight.
That's always fun and amazing all in itself. Before I introduce our speaker, let me explain how these meetings work. These meetings are recorded and are available within 24 hours after the meeting ends. To view the recording, you can use the same URL you used to get here tonight. The global math community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. I'll catch your questions for Leigh, so don't worry that the presenter won't notice your questions in the chatter. Leigh's also going to be very interactive in the chatter, so she'll probably grab a lot of them. Our speaker tonight is Leigh Nataro, and she's going to introduce herself. So I am going to turn it over to Leigh.
Great. Thank you very much, Jill. Good evening, everyone. My name is Leigh Nataro, and I teach at Moravian University in Bethlehem, Pennsylvania. This is my third year teaching there. I teach elementary statistics, business calculus, and math for elementary educators. My Twitter handle is mathteacher24. Prior to teaching at Moravian University, I taught in public and private schools. I love teaching AP statistics, taught geometry, AP calculus for a year, non-AP calculus, all sorts of things. But I definitely love teaching statistics. And the talk that we're going to hear tonight is one that I actually prepared for NCTM's conference that they were scheduled to have in Atlanta in September of this year that was canceled for COVID. So because of that, you get to see it here tonight. So even though this talk is going to focus on some ideas related to AP statistics, it is actually something that you can use for non-AP classes as well, or you might be able to adapt some of these strategies for some of your other high school or middle school math classes. So in this presentation, we're going to be learning about 4 different instructional strategies for teaching reasoning and communication and statistics. And the first 3 that you see listed here come from the AP Statistics course and exam description. We have error analysis, peer critique, building the model solution, and then the 4th strategy is a stand and talk, which actually I have a virtual variation that you're going to get a chance to participate in called the chat explosion. And then actually I've added a 5th bonus strategy called the quick write. So you're going to have several different strategies that you're going to learn about tonight. So one of the things I want to point out relative to these different strategies is that these different strategies are designed to promote equity and access for your students because they create a willingness in your students for them to share in front of their peers as they learn. These strategies promote both verbal and written communication around statistics concepts. I know writing about statistics is the hardest thing for students as they're learning about statistics, but the strategies that I'm going to talk about are going to help you to prepare them to write more. And these particular strategies that I'm going to be talking about promote a culture of collaboration where mistakes are seen as a valuable part of the learning process. So let's get into talking about the very first strategy, which is known as error analysis. This is where you give students an existing solution and have them identify and describe where the errors have occurred. So this is an example of a problem that I've used with my statistics students. And I will give you a moment to read it and see if you can identify where the error is located. There is one error in this problem. For those of you that actually teach AP statistics, this is a problem involving binomial probability. So I'll give you about 15, 20 seconds to take a look at that. And if you think you've identified the error, whether it's part A, B, or C, feel free to type in your response into the chat. Where do you think the error is located? In part A, part B, or part C? Part A, the probability that the ball goes in all 3 times. Part B is the probability that the ball goes in, misses all 3 times. And then part C is the probability she makes at least 1 shot in 3 attempts. All right, so people have recognized that it is part C, and here's exactly where that error is located. In identifying at least 1 shot, the student did the probability of making it the first shot and then missing the next 2 attempts. So they missed that idea of at least 1, meaning 1 or more. And you might actually point out to the student that they could actually find this probability by using their answer in part B. So here's another one that I do with my students, and I apologize that I must have had my slides out of order because I've actually circled one of the errors. So this is an error analysis example. This is for hypothesis testing. So when I do this type of example with my students, I have them work in groups, and I give them a problem that has some errors in it, and I usually tell them how many errors there are that they're looking for. This one has 4 errors in it. And as you can see, I've already circled one of the errors because I guess my slides are out of order. So in the null hypothesis, we should have the equality, and in the alternative hypothesis, the inequality. Right. Another place that we have an error is right here. Both of these numbers should be the same. And of course, the student has to figure out whether it's 0.42 or 0.37. Again, they're working in groups on this and discussing where they think the errors are. And by having that discussion and that communication going on, they can become better than eventually at writing their responses to questions like this. Here's another error in terms of the conditions. The n greater than 30, a lot of students think 30 is like this magic number. That large counts or normality condition is met when n is greater than 30 is if we're working with means, and this problem deals with proportions. So that one's incorrect. And then last but not least, they have the order of the subtraction wrong. And so that's the final error related to this problem. So this is an example that I would give to my students, and I would probably give them about 20 minutes or so, maybe 15 to 20 minutes, depending on the question, to work through that problem. This one, I don't have the conclusion here on the slide, but there was also the actual conclusion based on a p-value. So in terms of practical tips for error analysis, what you can do is you can gather work from one year and use it for a future year. So if you have a student that has made some errors in their work, that's okay. You can save that from one year and use it for a future year to help identify those errors. I often create my own papers that have mistakes because I want to make sure common mistakes are included. So I'll write on a piece of paper, a really messy handwriting to look like a student, and then have the students use that to identify any errors. And you could also use sample responses from released AP free response questions. So if you just Google AP statistics free response questions, you can see all the questions that exist that have been published and are available on the internet, and there's sample responses there that you can use as well. Or you can use sample responses from your local state assessment. The second strategy we're going to take a look at tonight is peer critique, and this is where students work in pairs or small groups to critique solutions to free response questions. So here's an example of a graph that I gave to my students this year where they had to compare graduation rates at different colleges. So We've got colleges A through F. Give you a moment to take a look at that. And the prompt does say compare and contrast, which is something that for some reason students aren't always good at doing that. And we'll take a look at a sample response here in a moment. We can see colleges A and F have quite a bit of variability in their graduation rates, whereas college B is a bit more consistent. So this is a sample response that I received from one of my students related to this graph. They said half of the colleges have a center above 70. So let's just go back and take a look at that. Half of the graphs have a center above 70. So I guess they're by center, they're talking about the median, although that would have been better for them to say median. And the other half have a center below 70%. 4 of them have a minimum that is below 60, and all 6 have a maximum of 70%. And all 6 have a max of 70 is definitely not true. Maybe they meant greater than 70, but they said all 6 have a maximum of 70. And the 2 outliers are A's min and F's maximum. So they think that this is an outlier, and they think that this value is an outlier as well, although they haven't justified why they think it's an outlier. In fact, those are not outliers, but it'd be nice to know why they were thinking that. So this student has quite a bit of work that they need to do. And so in terms of having students critique their work, this peer analysis and peer critique, I give my students a list of items that they want to think about. Did the student include these criteria? And what's the evidence for them including the criteria? Did they talk about center? Well, they do have the word center, but it'd be nice to know what they're referencing, the fact that they know we're talking about the median. And they haven't really compared them, right? They just talk about where they're located. Spread, it talks about minimums and maximums, but I don't really have a sense of variability. So I would have my students hopefully recognize that, but then also say it'd be nice to talk about the interquartile range. Outliers are mentioned, but the evidence of how they're justifying that there's outliers there is missing. Context, they have colleges, they have percentages. It would be nice if they said graduation rates, and hopefully the students would point that out to each other. And then other comments as well, just in terms of clarity, the fact that they're not explicitly comparing them would be helpful as well. So yes, you can just say critique the student's work, but if you don't give them a list of criteria or a list of things to look at, they probably won't focus on what they really need to focus on. So here's some practical tips related to doing the peer critique. First, do a large class critique. Focus on the work and not the students. So give a sample that you're going to critique together. You know, what is good about this response? What's there that they have? What's missing? You can scan student solutions in and remove the names and look at those as a class. Often at the beginning of the year, I will have students write a few sentences about a histogram. Here's a histogram early on in the semester. Describe this histogram. What is the distribution that we have here? What does it shape, center, and spread? What's the story behind this distribution? And then I actually scan student solutions, we remove the names, and then we can critique those. Giving students criteria to help with the critique is something I recommend, as I mentioned earlier. And then you can move on to having all students answer the same prompt and then share with 2 others for feedback. So this is something that they might be more comfortable doing if they do this already in their English classes. Next, we have building the model solution. And this is where students work in pairs or groups to assemble a sentence to represent a model solution to a free response question. This is something that can be done quickly. It takes about 5 to 10 minutes. And so if you teach in a longer block scheduled setting, this might be something that you want to do in the middle of your class to kind of break up your class a little bit. So the way this works is you first find a model solution, either that you've created or it's a model solution that's already been posted to an AP free response question. Then you split the solution into pieces of 4 to 5 words in length. So often a model solution is concise, maybe 2 to 3 sentences, and so you're just going to split that sentences into groups of words of 4 to 5. Then you're going to create 4 to 5 additional pieces that could be used in place of some of the pieces. So these could be based on common student errors, like using mean instead of median or sample instead of population. And then you put the correct words that are now all jumbled up, plus those 4 or 5 additional pieces or phrases from both those steps on separate index cards or pieces of paper. I actually create like a table in a Word doc, make the font a little bit bigger, put those in different cells in the table, and then cut them apart. And then I'll hand that to my students with a paper clip. I'll show you a virtual variation of this as well. And you give the students the prompt and the pieces of paper. You might want to tell them how many extra pieces of paper there are that are not part of the solution if you wish. So here's an example that I've created, and I will give you a moment to read this problem and then the question that's going to go with it. So here's the question that goes with this. If the population distribution was non-normal, would it still be appropriate to use the normal distribution to compute the probability? So we're focusing on the normal distribution and can we still use a normal distribution or not if the original population was non-normal? And so this is what I would give to my students. So we can see, I'm going to move my web camera out of the way here. Yes, the law of large numbers. Yes, the central limit theorem. And so the students would take these slips of paper and lay them all out in front of them and try to rearrange them and decide which ones are not part of this solution. And a lot of times students will have trouble getting started with this. I remind them that sentences start with capital letters and end with periods, so that might be a good place to start. And if we take a look back at the question, it is a yes or no question. So we're going to say yes, and then is it about the central limit theorem or the law of large numbers? It's definitely not about the law of large numbers. And the central limit theorem is not about the sample proportion, so we'd remove that one. And we'd also remove this one about being greater than 10. The central limit theorem has to do with a large sample size of 30 or more. Our sample size here was 50. And then these are the other two that would be eliminated as well. So when we rearrange these, and actually I've given this to my students on Google Slides, and then they just rearrange them on the slide deck themselves. Each group of students that's working together has one page of the Google slideshow, and they're working together on their assigned slide. And so here's the actual solution rearranged with those extra slips of paper removed. Yes, the central limit theorem says that the sampling distribution of the sample mean will become approximately normal as the sample size increases. Since the sample size is reasonably large, it would be appropriate to use the normal distribution to find the probability of interest, even though the population is non-normal. So that is building the model solution. A variation of the model solution would be to have a full model solution, but leave 3 or 4 blanks for students to complete, or give them options for what might go in the blanks. Think of like a pull-down menu. This is especially helpful for students who are new to the English language. So here's a sample of that. So this is a model solution for interpreting the slope of this least squares regression line, where x is the height of a student in centimeters and y hat is a predicted number of steps it would take them to get from the library to the gym. So the slope is, and they would fill a number in here. This means that for each additional, and they would put the number in here, each additional 1 centimeter in height, the number of steps to get from the library to the gym is predicted to go down by 2.3. So for students that are struggling with writing those sentences, giving them a sentence frame like this is a good way to get them to learn how to write those solutions. The fourth instructional strategy that I'm going to share with you tonight is something known as a stand and talk. And this is a quick way for students to think about a prompt and then talk about a prompt. And this is a concept that was created by Sarah Vanderwerf. We have had her speak at the Global Math Department a few years ago, and I heard her give this session about stand and talks, among other things, just different strategies she has for active engagement with middle school students. So this is the tips that I have generated for doing a stand and talk. There are no trios or opting out. So every student needs to work with a partner. If there's an odd number of students in the room, then you're going to pair up with whatever student is left over. You show students a prompt and you give them 30 seconds or more of individual think time first. That individual think time is really important. Then you're going to display the prompt in the front of the room. Yes, you could give the students the piece of paper, but I feel like it's more powerful when the prompt is in the front of the room. And at this point, you're just having them talk. They're not even writing anything down. They're just talking about what they see in front of them. And we're going to do a virtual variation of this in a few moments. I do not recommend using a stand and talk as a class opener. It's kind of like trying to start your car on a cold winter day in Vermont without running it for a few minutes first. It just is not good for the car. It doesn't always go so well. So I don't recommend this as a class opener because the students haven't really thought about math recently. This is good to do partway through the class. And then to keep the momentum, you would stand and debrief. So when I do this with my students, I say, okay, we're going to do a stand and talk. Here's the prompt. I display it in the front of the classroom. I give them some time to think about it. And then I say, okay, go and talk and find somebody to talk to. And they get up and they stand, they talk about the problem. And then when I feel that the conversation is starting to die down, then we debrief. If there are an even number of students, I'm circulating around the room to see what they're talking about and listen in. Occasionally, I'll find a student that's sharing an idea that I definitely want to be brought out. So I'll say to them, okay, I'm going to call on you first. You and your partner, you can share what you noticed about that graph. So here's an example. And actually, I'm going to have you participate in the chat for this. What story does this graph tell about the people who were on the Titanic? And so this is something I would share with my students in Unit 1. This is a mosaic plot. What story does this graph tell about the people who were on the Titanic? And we see the light blue corresponds to died. The darker blue corresponds to survived. Go ahead and type something in the chat related to that. What story does this graph tell about the people who were on the Titanic? So one thing I will say that my students often notice about this is that the height of the bars. They compare the height of the first class bar with the height of the second class bar and the height of the third class bar. But then invariably there's one student that will notice that the width of the bars are different. And so then the question is, what does that mean? Yeah, the proportionality of the third class passengers. Yeah, the fact that there was like about twice as many third class passengers as there were second and first class passengers. It looks like about the number of second and first class passengers combined is about the same as the third class passengers. And the story, yes, is the better the class, the greater the chance of survival. So there's definitely a relationship, right? Those two variables are not independent. Survival status and class are not independent. Excellent. All right, some great conversations there in the chat. So this is another way you can do a stand and talk. So when reviewing a concept, students don't want to admit that they don't understand a concept. I mean, who wants to admit that they don't understand something that you're going to be having a test on, in the next week or the next day? And so I did this with my students as we were reviewing for the AP statistics exam. I said, we are going to review our unit on experimental design. And I would like you to tell me words that you recall, even if you don't know the definition, just words that you recall from that unit, right? So students often will remember certain words, even if they don't remember what they mean. And so we generated this list in the front of the classroom. And I could have said, okay, these are words that came from this unit. I could have said to the students, which words don't you understand? And if I did that, I would have heard crickets. No student is going to want to admit that they don't understand what one of these words mean, or maybe that they don't understand what half of these words mean. And so instead of debriefing this or going over the definitions of these by just asking, what words do you want to go over? Which ones don't you understand? I said, okay, we're going to do this as I stand and talk. I want you to pick out a word or two that you don't understand or that you're not really sure about. So I had the students look at that list for about 30 seconds. And then I said, okay, you're going to go talk to somebody about the words that you don't understand. And so the students stood up, found somebody across the room to talk to. And there was a lot of chatter in the room, which was really freeing for the students because it's like, okay, I'm not the only one that's not sure about one of these words. And so they talked for, 2 or 3 minutes, maybe up to 5 minutes, depending on how many words they wanted to talk about. And then I said, okay, we're going to stand and debrief. What words do we want to talk about now? And so now students are willing to say, you know what, I'm not so sure what double blind means. And so then I said, okay, that's a great question. Let's see what double blind means. Who would like to explain what double blind means? And so I was calling on the other students in the class then to explain what the concepts were that their classmates weren't familiar with. And it was definitely a much richer experience than if I had just said, okay, which words do you want to talk about? I might have had one or two students say a word or two, but that would have been it. It was a much richer conversation. And the students were also then asking questions. If they weren't satisfied with a response that the student gave, they were asking questions about that response as well. So we're going to do a virtual variation of this known as a chat explosion. You might have also heard this known as a waterfall. This is a quick way for all students to have an opportunity to think, write, and share within a virtual classroom chat. So it's a good alternative to the stand and talk. However, there's no sharing with a partner prior to typing in the chat. And I think the sharing with a partner actually helps a lot in terms of the communication. So this chat explosion is a good alternative for a virtual setting, but it's not nearly as powerful as the stand and talk. So here's what I do when I do a chat explosion. I let my students know that this is a chat explosion, which means I want you to type your response in the chat without hitting enter until I tell you to do so. This is important because you want to make sure all students have a chance to type. Otherwise, if you ask a question, you're going to always have just 2 or 3 students share instead of more students sharing. And so by doing this as a chat explosion, more students have time to think about and type about the prompt. Make sure you give adequate time for thinking and typing. That's really hard to judge in a virtual setting. My recommendation is to have yourself type in a response, like the students would be typing in a response, erase it, type in a response again, and that might be enough time. So embrace the silence. Don't talk while students are trying to type and think. And then you say, okay, hit enter and let the chat explode. And then summarize what you see in the chat. So this is what we're going to do as a chat explosion here in a moment. This is which one doesn't belong. But rather than calling it which one doesn't belong, I think we need to get rid of that phrase, which one doesn't belong, and call it which one is different instead. So I'm going to start to call it which one is different instead of which one doesn't belong, because belonging means something, whereas which one is different. Differences are important and we want to recognize them. Whereas which one doesn't belong, it feels like something's being left out. The photo credit here goes to Vicki Greenberg, who is an AP statistics teacher in Georgia, I think near Atlanta. So in the chat right now, I would like you, as is a chat explosion, to type in a number for which one is different, whether you think it's 1, 2, 3, or 4, and a reason why. Which one is different and why? But please wait until I tell you that we're going to hit enter. Which one is different and why? All right, go ahead and hit enter. We've got responses of 1, 2, 4, all different reasons. There's a weaker correlation in 1, stronger correlations in 2, 3, and 4, or at least stronger cluster of points in 2, 3, and 4. Curved in 2 versus 1, 3, and 4, more linear. Looks like 1, 2, and 3 are positive, but 4 is negative. I don't know if anybody chose 3. 3 appears to have some points that are outliers. Yeah, some points that are outliers. So definitely anything that is which one doesn't belong, or which I'm calling which one is different, is something that you can use as a chat explosion. You could also use it as a stand and talk. Here's another one. We'll do this as a chat explosion as well. Take a moment to type in the chat, what do you notice or what do you wonder? All right, I haven't given you any context other than what you see in front of you. This graph shows average SAT writing on the x-axis and percent of 3s, 4s, and 5s on AP exams on the y-axis. So what do you notice? What do you wonder? We're going to do this as a chat explosion. So take a moment to type, but do not hit enter until I tell you to do so. What do you notice? What do you wonder? And remember my suggestion to type your response, erase it, type your response again, and then you can tell your students that you're ready for them to hit enter. Go ahead and hit enter. How many students does it represent? Yeah, so the question is, are each of these individual students or are these schools, right? I didn't give you that context. Seems that there's an increase in average SAT writing scores and an increase in the percentage of 3s, 4s, and 5s on AP exams. I wonder if the point closest to 0 is a possible outlier, right? Possibly. That would be a good question to ask your students. In case you're wondering about the context, these are actually actual average SAT writing scores and the percentage of 3s, 4s, and 5s on the AP exam for, I think there was 20 points here, or maybe 12 points, 15 points. I've lost track of how many points. I think it's 15. But it was a random selection of 15 schools in California out of, I think it's over 1,000 schools. So private and public schools, larger schools, smaller schools. But this is a random sample from that data set. And it is the average SAT writing score for the students at that school and the percentage of students at that school that got a 3, 4, or 5 on the AP exam. And this is actually a data set that I use with my students when we talk about inference for slope. And so now we're going to talk about a bonus strategy. This is called the quick write. This is where students write for a short, specific amount of time about a designated topic. So before we have students write, 3 or 4 sentences or 5 sentences about something, we need to have them write just 1 or 2. And so this is where students write for a short, specific amount of time about a designated topic. And just a special side note, you don't need to provide feedback on everything that students write. It's really important for them to write just as part of the learning process. So they do not need to have feedback, and you do not need to collect every single writing assignment that they do. So here's what I want you to think about, and we'll vote in the chat here in a moment, so do not respond just yet. Which of the following would provide you with more evidence that a coin is not a fair coin? So this is something we do when we start to talk about inferential statistics, making decisions based on data, right? Here's our data: 6 heads in 10 flips or 8 heads in 10 flips. Which of these would provide you with more evidence that a coin is not a fair coin? These are your only options. So in the chat right now, type either 6 or 8. Which do you think would provide you with more evidence that a coin is not a fair coin, the 6 and 10 or the 8 and 10? All right. And pretty much everybody sees that as 8, all right? And this is something that students easily pick out as well. Well, the 6 out of 10, I mean, that's pretty close to 5 out of 10, but the 8 out of 10 is further away. So 8 out of 10 would provide you with more evidence. So this 80% sample proportion as opposed to a 60% sample proportion. And that's when I go to this one next. So you said that 80% was more evidence. But what about this one? These are both a sample proportion of 80%. Which of the following would provide you with more evidence that a coin is not a fair coin? 8 heads in 10 flips or 80 heads in 100 flips? Go ahead and type in either 8 or 80 to respond to that question. Which one provides you with more evidence that a coin is not a fair coin? 8 heads in 10 flips or 80 heads in 100 flips? Definitely the 80. And this is really interesting because both of them are 80%. 8 out of 10 is 80%. 80 out of 100 is 80%. But the students have that intuitive sense that a larger sample size is providing them with more evidence in this particular situation. So this is one of the ideas that I use towards the beginning of our unit on inferential statistics. So a few final thoughts to wrap up, and then we'll have time for questions. Encourage writing with your students. They don't have to have all their pieces of writing collected. You can have them share with a partner and critique, but you don't even have to do that. That last example that I just gave, I just have them write down the reason why for themselves so they can remember that in the future. Yeah, I'm asking them to defend their choice, definitely. I just didn't have you defend your choice in the chat just because we'd already done quite a few typing in the chat. So I was kind of just saying, just typing your response. But yes, I'd ask them why. So which of the following would provide you with more evidence, and then why? So encourage writing with your students. Give them sufficient time for thinking. That is something that I sometimes struggle with, but I'm getting better at it. So asking the students a question, giving them a few moments to think about it, and then I ask them the same exact question a second time, worded the exact same way. Because for some students, it's like, wait, I think I heard that question, but I'm not sure. They need to hear it a second time. Let students talk. And the reason why the stand and talk is more successful than just turning and talking to your shoulder partner is because they actually have to get up and move around. And just that process of getting up and talking to somebody that's not immediately beside them and having them stand and debrief, it just makes the conversation richer and it keeps them actually on task a little bit more. But let the students talk about the statistics. And make sure you value mistakes as part of the learning process. I know that the one thing I tell my students is you need to think about the fact that you are not quite there yet. You're going to get there. And that these errors that we see are common errors. We need to learn about them together so that we can learn from that and not make those errors in the future. So this session was a little bit shorter tonight, but I want to make sure we have plenty of time for any questions that you might have. So feel free to type any questions you might have for me in the chat. Yeah, so the recording is going to be posted probably about 24 hours after this session ends. I'm actually also the host coordinator for the global math department, and there was a time slot that they needed somebody to talk, and I had this talk that I was going to give at NCTM, and then when NCTM was canceled, I didn't get to give it, so I had this talk ready to go. Yeah, error analysis is something you can do in lots of classes, not just AP statistics. I've actually done it with my business calculus students, especially in problems that are a little bit more complex, because it's really important for students to learn to identify their own errors, rather than just saying, well, I didn't get that answer at the end. Well, you need to go back and take a look. Did you make a mistake at the beginning? Is it somewhere in the middle? Is it at the end? And I also like about the error analysis is I usually have common errors that students make. I tell them, look, these are common errors that I've seen students make. These are common errors that you might see in your own work someday. Do I have other which one doesn't belong for stats or website you use? I have a few that I've created. I think I have a folder that I started with them, but I don't have it posted anywhere. So, Valerie, if you send me an email or if you reach out to me on Twitter, I can send that to you. I do have a few of them. And there is a website just in general for which one doesn't belong. But they're I don't want to say they're easy to create. They can be a bit challenging to create. I've created one for distributions. I've created which one is different for hypothesis tests. Usually you can do 3 of them. It's that 4th one that's a little different because they all have to have 3 things in common and then something different in that 4th one. All right. Bridget, you said you use the data regarding SAT and 345 scores on APs. Can you share the website source for the data? Yes, I can. Let me see if I can find it really quickly. The person that created that activity was Jeff Eicher, and I found it on the AP teacher community. But I'm going to find it really quickly here. It's AP pass rate and average SAT writing scores. I'm going to share this in the chat right now. I just got to make sure that the link is so anyone can view it. All right, it says I copied the link. So that's for the average SAT writing score and 345. So that's the kind of the worksheet that goes along with it. I see several of you clicked on the link because I can see there's people in there. And so this actually, I'm trying to think if it tells you where, the formatting is a little funky right now in the Google Doc. So you might have to copy and paste that and put it in something else. But there is a shortened URL. I'll put this in the chat as well, which gives you the website that has all the data in it. I think I just put that in the chat. So that's the website that has all the data, and it has the same name of the school, the district, the county, the enrollment, and the average SAT writing score, and the average and the percent pass rate. And when I do this with my students, it's sorted by lowest AP pass rate to highest. I just go through the data set and ask them, what do they notice? What do they wonder? And just even scrolling through the data set, they can see that higher average SAT writing scores are associated with the higher AP pass rate. Let me see what other questions. Creating your own which one doesn't belong guidelines. Thank you for sharing that, Carissa. And Jill shared some resources as well, same but different.
There was also one in there for which one doesn't belong by Carissa.
Yep. Yeah. And I really feel like I want to move away from calling them which one doesn't belong as opposed to which one is different, because I feel like differences can be celebrated. And which one doesn't belong, I don't know. I'm trying to like use a different word for that.
That the link that I shared, the same but different, I just took a webinar on that, and that was her theory behind it too, was you look at them and you see what's the same and then what's different about them. So I thought I'd add that in there.
Yeah. And that same and different idea is actually something that I also have my students look at for multiple choice questions. So in terms of AP statistics multiple choice questions, I would tell students, look at the answers, especially if it's one that's involving numbers, like what parts of the answers are the same, which ones are different, and then you can focus on what's different about them and maybe eliminate some answer choices because you notice what's the same versus what's different. All right. I don't know if I see any other questions in the chat, but if I missed anything in the chat or you have anything else that you want to share, please feel free to reach out to me, nataros@moravian.edu. I also have my personal email, nataro@gmail.com. I just put that in the chat as well. Or you can reach out to me on Twitter. MathTeacher24 is my Twitter handle. I think that's about it for me tonight.
All right. Thank you very much, Leigh, for sharing. I think everybody walked away with some really good ideas, even me who doesn't teach statistics in middle school, but I picked up some things. So I hope everyone is able to join us on November 2nd. Libo Valencia is going to be presenting on building community and increasing student engagement. Libo presented a couple months back. I hosted that one too, and we walked away with tons of ideas. So I would highly recommend joining us on the night of November 2nd. Thanks everyone for coming, and remember you'll get the link for the recording very shortly, or you can use the same URL that we got you here tonight. Have a great evening, and thank you.
Yep. There's one person that asked about a copy of the slides, and so I'm going to put a copy of the slides in the handouts tab at the top of your screen. Yes, this is it right here. So this is a PDF of the slides. I thought I chose the handout here. 1 second. It says it's saving. So if you click on the handouts tab across the top above the chat, you should be able to see the PDF of it right there.
I'm seeing it, so they should be able to see it.
All right. Great.
All right. All right. Thanks, everybody. I'm going to stop the recording.